So the next in stream class that I'm going to discuss is the filter input stream example or the class. So technically, I mean, there is no difference. I would say the reason behind is like because this particular class just don't have any extra functionality. The only thing it has is like it has uh, it is extending the input stream. If you could see, it is just simply extending the input stream class. uh, there is no all the methods that is in input stream you could see in the filter input stream. The only difference is like there is a few more subclasses which is extending this filter input stream. Otherwise, from the functionality perspective, it is same. And we could create this filter input stream by passing this file input stream as an buffered input stream here. So we could create it like this, and let me compile this example. Java C filter input stream Java. Okay, try without cache. I need to close the cache. Let's see, exception for now. Okay, I need to import this class as well. I input stream. Java filter. So see, so this is reading the file, and if after reading this file, if I'm calling the available, it is simply reducing 1 byte and showing it. So this is the same method that is available on the input stream. I just showed you for to demonstrate that file input stream class. The next class that we need to implement is the object input stream. But before this uh, class, discussion, I would like to discuss about one more thing, that is serialization, because this particular class is used in the serialization concept. So serialization, it's very difficult to make you understand serialization right now, but on a high level, I will try to give you one example that how serialization work and where we need it. So let's say uh, there is one program which is written on Java, and that is written on the JVM1, or you could say that that is machine one. Let's say I am writing this application in my machine, that is JVM1, right? And let's say this is the Java program, and it has like the class, as let's say it's a person class, and it has some attributes like name, roll number, something like this. Let's reduce the size of this, right? And I want to send this object, this class information, to other system. So let's say there is another machine, which has JVM2, right? Let's say it's a JVM1, and there is a network system between these two. Let's say I'm sending this information over the network. This is some kind of network. So because this particular class that has the data, let's say name is in string format and roll number is in integer. Let's say name in string and this roll number is in integer format, right? So we cannot send it directly, to this from here to here. It is not possible because the two machines always communicate in a bits and the bytes format. So first what we have to do is like we have to convert this particular object into the byte format, which is a byte stream, because this particular class will not be just one byte. There will be n number of bytes, whatever the size of that particular object is, right? So we have to convert this into the byte format. This will be the bytes, right? So it will be converted into the bytes, then we could send it in a stream. So whatever the information flow through the network, that will be the stream of bytes, right? So when we convert this object into bytes of a stream, this is called the process of serialization. And once this machine will receive it in its that byte format, and it will convert it into again this particular class format, because it need same format, right? Then it is called the deserialization process. Here we have to, before, once we receive it, the stream, we have to deserialize it. Deserialization. So whenever two computers communicate with each other, they always communicate in the form of bytes, which is a stream of bytes, and there will be serialization and deserialization. Even if you will, try to save this record into some kind of database. Let's say it's a database. Uh, this one is the database. There also, you have to serialize and deserialize your object, right? If I will send this data to here, from here to here, I have to serialize and deserialize the messages. So this is how serialization and deserialization works. So remember this thing, like whenever you are sending information from one medium to another medium, it could be network, it could be database, it could be like the file, then you have to serialize and deserialize your object into bytes, and or the stream of bytes. So this is what serialization. So there are some methodology through which we could serialize. So you have to actually implement serialization interface. This particular serialization interface is a marker interface. Now, what is marker interface? That we need to understand. So, marker interfaces are those interfaces which don't have any implementation, any method, any nothing. It is just a blank interface. So, I will go here. dog. I will go to serializable. You can see here that this interface, all know sub interfaces. These are the sub interfaces which is implementing the serialization. This is a class of implementing the serialized interface that do not will not have any their state serialized or deserialized. So the marker interface you will will it will not contain any method or anything. It is just a blank interface. So we have to implement serializable interface if I want to make any object as a serializable. That we will discuss it in the coming session. So in this example, I'm going to explain you the object input stream. So as discussed about the serialization, so uh, this object input stream actually read the data, whatever the object output stream has written it on file, or it could be some other platform like the network. So in this case, what I'm doing is I have created one class employee with name and the employee number, two attributes or the variable you could say, and I just created one constructor for this to pass the value to this class. And I also am implementing this serializable, right? This serializable. So this particular class, so that this class I could serialize during the output stream. So here I'm passing the value Ravi and the 101. So Ravi will come to the name and the 101 will come to the roll number, employee number. So once this is initialized, I'm creating one object for the file output stream with the name employee.txt and passing this file into the object output stream. And I'm writing, or I'm sending this, not sending, actually I'm writing this employee object into this output stream. That means this particular data is written over the this employee file. So if I will go to the file input stream, here I'm creating again like we did in the last example. I'm just creating the input stream for this file object, and this file object I am reading through this object input stream. I am reading it as a object input stream because this particular class is an object, right? This will come and we are going to read as a object. So I'm saying input read object. I am uh, explicitly casting this to the employee object. I'm saying that read this object from input stream and convert this into the employee object and print whatever the employee object name and the employee has. So if I'm going to compile this, so let me compile this. If I'm running it, see, I could read Ravi and 101. What if I will remove this serialization? Let me compile this. There is no error in the compilation, but I cannot send or write that data, object data, into the output stream, and I cannot read as well. Remember this. So this serialization is very important. Without this input object stream and output object stream will not work. So the first class from the output stream is the file output stream. So for that I have created one example. So in this case I'm creating file output stream object and I'm passing this test output.txt. Remember that this class and this file should be at the same place, I mean in the same directory. Otherwise you have to pass the complete path of this file txt file, because I have created both of them at the same place. So I'm not giving the complete file, I'm just giving the file name with the extension, and I'm writing this 65 number 65 in the this f out object, and I'm closing it. Right, there is one more thing that you could do. You could simply flush here, so that any byte remaining in the buffer, that should be written on the object. Sometimes it happens like uh, it the buffer is not flushed because uh, you know it just remain on the memory, because only after a certain size of the buffer, fout actually this file output stream write object flush the object. It does automatically, but sometimes it don't have. So to make sure that everything is flushing out into the object, so I'm just writing this method dot flush. So in this case, as I discussed, I'm passing this 65 as the number. So if you can see, there are three different version, overloaded version of the write method. First is the byte. You could piece the byte array. Second is the byte with the offset and the length. Third is the write the integer value. So bytes are usually the integer byte, so we could pass the integer value as well. So either you could use this or you could add this array. So because I'm just testing it with the one integer, so I've written this right, and I could pass this integer as a value here. So this will call directly this particular method. So if I will compile this, java c file output string java file output string. See, this has successfully written that content into that file. So the file was test test example test output, right? Let me open it. So if you see, this has written the a, which is the integer numeric number from the 65. So that is what it has written, right? As usual, I could simply, through the input stream, I could read it in a other another class, so that is also possible. Another example of the output stream is byte array output stream. So if you could see in this byte array output stream example, I just created one string with the, my name Ravi Thapa, and I created one object of the byte array output stream, and I'm getting the bytes from this string and writing it into the out object, which is a byte array output stream object. And here what I'm doing is I'm getting this byte array in the byte format using this out, and I am printing each character, byte data, right, and converting explicitly uh, uh, into the char array and printing it. So this is doing, I'm doing one by one. Another way of doing the same thing, like I could directly convert this out object to the string. So both are same. I mean, it's up to you that what you want to use. So if I will compile this byte array output, and I will run this, see, it is printing the my name. So these are, I mean, it is similar to the input. The only thing is, instead of writing, it is reading the byte array from the byte array output stream. So the last two classes that is very important, that is the buffered input stream and the data buffered output stream. These two stream classes actually being used because it contains higher number of buffer, bytes in the buffer. So the performance of the reading and the writing is much improved, because earlier we were writing per byte. So now, because you could keep higher number of bytes, so the performance will be increased. So that is the purpose of this. So the another class that I wanted to discuss about is the file reader and the file write sorry, the buffer reader and the buffer writer. So these reader and the writer classes are those classes which could actually read and the write the the text or the string from the file as a line. You don't have to write data into the buffer, because in a practical scenario, and when you are going to read or the write the file, in case of like a file, right? So you cannot read or write byte by byte. That will be very slow. So usually what people use is like they read or write line by line. So in this case, this support reading and the writing the data in a line by line. So in this case, like for example, what I'm doing, I'm creating one file writer and creating this file, and through the buffer writer, I'm passing this file object, file writer object, and I'm writing one line and putting another new line. Then I'm writing the second line, I'm putting the new line similarly, and I'm closing it. Once it is written, I could write the data by using the file reader and the buffer reader, and I could read line by line. So this way the reading and the writing process will be much faster in a practical scenario. So if I'm going to read and write this, I will compile this and run this. You could see I could read and write line by line. So the file name was text. So if I will go here and if I will open it, you could see this is written as a text, not in a byte format. I don't have to make any conversion. So it is simply written string as a text, and that is also in a line. And I could write and the read in the buffer. So in many cases, what happened, like the file is not there in the location, and you need to create a new file. So how you can create a new file, that I'm going to explain in this example. So for creating the new file, you need to create object to the file class, which is available on the java.io. And I could give the path. Let's say I want to create file at this path. So what I will do it, I will just copy this to escape this slash. So I will write double slash. Let's say text file dot txt. I want to create the text file. So I will simply save it file, and whenever this file is created, it will send you the result in a boolean format, that is the result, so true or false, right? So if file is created, then I will say okay, file is this. If file is already there, then it will go to the else part, and it will simply say that the file is already created, or if there is an exception, then it will give you the exception. So let's say java c create file example.java java create file. See, this file is created. Now if I will run it again, because that file is already created, it should give the file already exists at the location. File already exists at the location. So this is how you could create a new file through the file object. So in this example, I'm going to explain that how you could create the directory as well using the file object or the file class. So for that, I have to pass the path where I want to create, or you want to create the directory. Let's say I want to create the directory here. Let me escape it. So I will. So there are two ways of using the file bar. Either you could escape with a double quote, or simply you could use the backslash. Both are fine. It's up to you what you want to use. So now I want to create a new directory. Let's say new dir and saving it, right? And if I want to create multiple directory, I could also create the multiple directory. Let's say new dir2 slash new dir3. That is also possible. So I'm just creating it. Let me compile this. Java c create directory java create directory example. So it is simply define the main method as the static, public static. Okay, I have written the method only. Let me create the object, sorry, the main method, public static void main string args. Let me call this complete logic inside this, right? So I could compile it now. When I'm running, directory is created. So the first is the new directory, second is the new directory 2, and the new directory 3 with the 2 levels. So if I go there, new directory, and there should be a new directory 2 with the 2 levels. So there is that Java programming new directory 2 files exist. Okay, I need to pass this. So let me recompile it. Multiple directories are created. So if you could see new directory 2 and new directory 3. And if I want, if directory exists, then I could create the file inside that as well. So last example that we were using, like to create the file. So what I could call, I could do is like I could call this method. If does not exist, then create the file. If exist, that means else create the file. If directory exists, then create this file. So I will just simply put this logic inside this block, or I could create the method as well. To save the time, I'm just writing this. So I will pass the complete path. Now, yeah, it is correct. Let me compile this. Okay, there is error, interface expected. I think this one is extra. IU exception. I need to call the exception as well. So if I will compile this, now again it is okay, file is already there. So I could use the same file object as well, that is also possible, but I don't want to do that for now at least. File 2, file 2, file 2. This should be fine. Java create file is there. So if I will go inside that directory, let's say new, see this file is created. So this is how you could create the directory, and you could create the file inside that directory, and you could create multiple directory as well, and you could create the file inside that directory. So all these possible cases are there. So this is another example to write the data into the file. But here what I'm doing is like I'm writing the data into the file in a append mode. So whenever I am adding new text, it will just go in append into that particular text file. So what I'm doing, I'm writing this file, that is append data.txt, and file writer, I am passing this file name with true. So if I would go to this particular class implementation, so you could see there is a method. See, there's a method fill a file writer. It has file name and the boolean append mode as a true or false. That so you could write that file in a append mode. So And what I am doing is like I'm getting the argument and appending it with the slash n. So what it will do after appending the text, what it will do is like it will just put the next line, and I'm closing the file. So if I will compile this, Java write example, and if I will say hello, you could see there it is appended with the data hello. Now if I'm again calling this Java, I need to, can I refresh it? No, it's not that. So I could open it again. It is printing or writing the neckline that is Java. So this is how you could uh, you know write the file in the append mode using this class. This is the end of this topic. For more videos like this, please like, share, comment and subscribe my channel. I will see you in the next video with another interesting topic. Thank you for watching my videos.